and welcome to Friday again. Hope you've had a decent week, and weather's starting to get nice out there. So hopefully we can all get outside a little bit, get a little fresh air. I think it's good for mind, body, and spirit. And obviously, I hope you have a good morning and a good weekend. Today, my agenda is kind of two parts. We are officially starting our Python unit today, and it's the largest and likely most sort of important section of the course. And people who have been doing well in Reborg, and that's most students. Most students have been doing really well and have been very good about asking questions when they're struggling with concept. And hopefully, I've been giving enough hints and guidance to point you in the right direction for the ones that you're struggling with. People who do well in the Reborg unit and have a strong understanding of conditionals, so the if, elif, and else statements, as well as looping, particularly using while loops, tend to make a nice transition into Python and not have too much difficulty with the basic structures and the problem solving. Another thing that's really important, and I've been trying to emphasize this the entire way along, is making those little bullet point algorithms, even just doing them as comments at the top of your code, and then kind of crossing them off the list or deleting them as you move through your algorithms. Those are very, very handy. And so I'm here to support you. Hopefully it's sort of a gentle introduction to Python as you go through it. One thing I want to note, and I tried to make that a little bit more clear this Quint as opposed to last Quint, is I've got a digital textbook up there. It's an open source textbook called How to Think Like a Computer Scientist, and it's a really, really good textbook. I put it up there as an additional resource for us, as supplementary information. And I don't think I had that maybe tagged well enough the first or last Quint. And I had a student who went through the entire textbook and did everything, and it's like 300 pages. So I want to make sure that everyone understands that that's a supplementary material, and it is a really good textbook. So if you're interested in Python, you like what we're doing, and you want to delve a little deeper into it, there's 3 or 4 chapters in that textbook that I usually use in Computer Science 30 as a continuation of what we've learned here. So there are things in the textbook that you will not see in this class, but that are crucial to understanding of object-oriented languages. So if you do want to extend your learning, or you like Python, or you're moving, you're going into Computer Science 30 and you want to sort of get a jump on it, going through the chapters on classes and object-oriented programming is certainly something that you can do. If you're struggling with any of the assignments or any of the basic structures, for loops or while loops or whatnot, and you're not finding my videos or additional information on the class website as helpful as you need it to be, you can certainly just Control F and have a look for that particular phrase in the textbook, and you might like that explanation better. But as always, I'm here. You can always just email me. So just to make you aware that that resource is there. My hope today is that everybody's going to get through 4.1 and possibly 4.2 if you kind of want to move ahead. 4.1 is not that difficult, and not that it's just a gentle introduction to what Python is and sort of the basic understanding of how to use an IDE, an integrated development environment, for your code, and basic introductions. Taylor, yeah, no problem, Taylor. And so that's my hope, is that today people will do that sort of gentle introduction, and possibly move on to 4.2 and actually get into the structure and data types and variables and whatnot, and that would be great. So today, I wanted to go through just sort of a couple of setup things with Python. And some very basic commands that you're going to see in 4.1, 4.2, 4.3, and it's by no means an in-depth demonstration of what you're going to need to finish the course. But I figure if I can use this time where we're really, really just coming out of Reborg and going into Python, and try and connect the two, it might help moving forward. So that's my goal for today. It's not going to be particularly heavy lifting, but if you do have a Python development environment, one of the ones that I recommended you download, PyScripter, PyCharm, Thonny, and you could use Replit online, but I noticed Replit's got some problems with their debugging feature right now, so it might not be the best as far as being able to test your code. I use PyScripter. I have used Python. I have used Thonny in this class before. Both of them work equally well. I just find that that PyScripter has sort of stripped out the things that we don't need in this class, so it's maybe a little easier to navigate, a little easier to debug with. So if you do have the option, I do recommend PyScripter over the others, but they'll all be fine. They'll all be fine in this unit. If you have any trouble installing Python or opening up PyScripter or any of those things, just email me and I'll help take you through it. Most of the time, it's pretty self-explanatory. Those links that I posted at the top of the unit will take you right to the page where you download, and it'll, it's sort of like just a regular double click to install kind of thing. So if you have any trouble with that, please let me know. If you have already downloaded it and installed it, today might not be a bad idea to just kind of open it up on the side, or minimize, open it up on the side, or split screen, or have multiple windows, and maybe practice a few of the things that I'm going through. A nice little shortcut in Windows, if you don't have two monitors. By the way, if you do have two monitors, you never go back to one monitor. You get very used to the convenience of having two different screens and two different things going at the same time. If you likely don't have two monitors, a handy little Windows trick is holding your thumb on the Alt key, and you can literally do it right now. Just put your thumb down on the Alt key, and then if you tap the Tab key, it'll pop up all the windows that you've got open, and then you can just, keeping your thumb on the Alt key, you can just keep tapping the Tab key, and you'll notice that it cycles between windows. So if you're doing a video tutorial while you're coding, even in Reborg, if you've got sort of the open text information on one browser tab, and then you've got Reborg in the other, I guess tab switching in Chrome or a web browser isn't that difficult, but in this unit, you'll have Python, which is a separate program, open, and then you'll probably have the videos in your web browser. If you use that little Alt-Tab trick, you can just very quickly Alt-Tab, and go back and forth. So you can Alt-Tab, watch a little bit, hit the space bar to pause the video, Alt-Tab, go back, type a little code, see how it works, Alt-Tab back to the video, hit the space bar to play it, hit the space bar to stop it, Alt-Tab back. So that's just a really efficient way, if you don't have two monitors, of working through the materials. Another trick for Windows is you can grab the top of your any program, essentially, drag it out the side of the screen, and then it'll split screen it, so it'll put it exactly halfway in your screen, and you just grab your other program and drag it to the other side, out, like right out the side on the left side, and let go of the button, and it'll do the same thing. So you can actually have split screen, half and half. You can have your program, your coding on one side, and you can have the video on the other side. So that's a couple options. I'm not a Mac person, so I'm not sure, but I strongly suspect that Mac has the same functionality. Maybe it's the Option key in Tab or something like that, but that's a quick Google search. And I'm sure they would have a split screen option too. You just have to maybe Google it and find out what it is. Linux users, I think it's the same as in Windows. I think I have one Linux user. One person said they had Linux, but it might have been as an addition to a Windows machine or something like that. Always impressed if some people are running Linux. Okay, so that sort of takes care of what I want to do today. And one more thing, I do want to talk about the final project a bit, because I suspect most people have kind of put that on the back burner while they're trying to get through the Reborg stuff. But it is a portion of your final mark, and it does give you an opportunity to explore a little deeper into something that's an area of interest to you. So let's talk about the final project first. I may have mentioned this in previous videos. It's usually a larger portion of our final assessment. In an in-class setting, I typically have it at about 15%. And I've knocked that all the way down to, I can't remember if it's 5 or 10. I think it might even be 5 this semester. And the reason I've done that is not because I don't think it's important. The reason I've done that is class hours is not the same thing as calendar days. We have the same amount of hours in this class that we would in a physical building. You're just doing 2.5 every day instead of 1. So you still get the same amount of theoretical learning time in the class if you're doing your 2.5 hours a day. But when you're doing a large project and you're doing it independently and you're doing it outside of class, it's those calendar days that tend to be a bit more important, right? You want to, you let the idea, you think about it a bit at the beginning of the semester, and you let your ideas percolate a little bit as you learn the information. Then you make a decision probably somewhere around the halfway point, and then you've still got 2.5 months chip away at it and do any extraneous learning that you need to do in order to build it and test it and polish it off and get feedback and then submit it at the end of the semester. And with an 8-week quint, you just don't have that kind of time and the opportunity to do that really in-depth learning and reflection along the way. It feels kind of rushed, and it is kind of rushed, and that's just a natural drawback of the quint system. Is you get the same amount of class hours, but the calendar days do make a difference. Everything feels really rushed because it has to be. And teachers understand this too. That's why I really try to get projects handed in on time, and then hopefully you're noticing I'm marking them really quickly and I'm getting back to you really quickly, because feedback's only helpful if it's timely. So when you hand something in to me on Monday, I want to make sure you get it back Tuesday or Wednesday at the latest. And I usually do a pretty good job of that, because if I leave these projects for or these programs for a week or a week and a half in a quint system, that's really like getting feedback a month and a half later in a physical regular semester. And that's by that point you've moved on 2 units. So it's important for you to submit things on time, and it's also important for me to give you feedback on time, and it becomes so much more important in a quint system where we've really compressed our calendar days. Okay, I'm just going to share my screen for a second. I just want to show you where the project information is. If you haven't already looked at it, it might be a good time to start thinking about it. We down the Inception rabbit hole there? Can everybody see my web browser? Should be.
Yeah, we can see.
Okay. Perfect.
Do you want to show us how to split your screen? How to have 2 windows at the same time?
Oh, sure. Why not? I don't know if this will actually work. If you will be able to see this, but I just want to make sure I don't have anything sensitive in the background. I don't. That's just Math 9. You can see that. Okay, so here's a quick example of how you do that split screen. And you know what? It actually might not work because I've got 2 screens going. But so you just grab your web browser right at the top, and I'm still holding down the button. And when I drag this all the way to the left, I don't know if you can see it, but on the desktop there's a little white indicator that says I'm going to make this half your screen. And then when you let go, it does turn into half your screen, and then it shows you the other programs you have open. And so you could go to your other program, and it automatically fills up the other half. So you actually, if you do one side, you don't actually even have to drag the other one out. It just kind of automatically does it. And I'll just double check to make sure that that's true, or if that was just a coincidence that window happened to be half a screen. So I drag it out to the left, and I get half a screen, and then let's say I pick this one, and it's automatically the other half. So it's actually even more intuitive than I remember it. And then I was telling you about the Alt Tab feature. Well, I'm just Alt Tabbing right now. So Alt Tab to my web browser, Alt Tab to my Adobe Acrobat. So I'm just flicking back and forth between the 2 right now. You see how quickly it works. But if you hold down the Alt key and just tap all at once, it pops up this menu. And then you can just keep hitting Tab until you find the one you want. So there's another web browser. Unfortunately, it's in my other screen, so you can't see it. There's that Math 9 we're talking about. So handy little tricks there that you can use to maybe make your life a little easier. All right, I'll go into student view here. Hopefully that doesn't kill my my video. Everybody can still see what I'm seeing. Okay, so learning modules, nothing strange there. And we go down to number 6, final project information. And what I've done here is I put as the top level item, and maybe I should move this, but I've got links to some projects that have been done just in the last 2 quints. There's some really good ones in here, so I figure that's not bad. All I've got up here is some Scratch projects, people who have made games, fun little games. I've got a couple of Python programs in here. One of them, this Forex calculator, it's a like a money currency converter program, and you do actually need to install a certain library from for Python to make it work. So if you download that one and you're opening and you're not sure why that's working. I think there's instructions actually inside the Python program that shows you how to install the other one. But don't get frustrated. Don't frustrate yourself if this isn't working correctly right away. It's because you probably don't have a library, a certain library that's needed to work installed on Python. And if what I just said was nonsense, don't worry about it. We'll learn about that stuff later. But I believe the Hangman one and Game 2, which is Mastermind, I believe those two work without having to download anything else. So you just download the zip file and extract it, and then inside that zip file there'll be like a hangman.py file that you open, and then you can see the project. And there's a couple other ones here. This is a Shockwave game, so it's made for Flash. Flash was deprecated, meaning it's because of some security flaws, which really didn't affect the average user that much. It's not being supported anymore, but most web browsers will still be able to open this, so you can see what it looks like. And this Pac-Man game, I honestly can't remember what this Pac-Man game was built in, but it wasn't Scratch or Python or one of the other languages that we have explored. This person kind of went off in their own direction. I'm just actually going to click this to see if I can run it in my browser. Maybe you can just see what it looks like. Mm-hmm. So it gives me the little warning message here. This could be dangerous, but I'll keep it because I know it's not. And then I'll run it. See what happens. Can you see it right there?
Yeah, I can
see the brick breaker game. Okay. So he decided to work in Flash and make a program of brick breaker game. Whoops, and I lose. So anyway, that was pretty cool. Why? Because he wanted to learn a little bit about Flash, and making a brick breaker game was a good way to demonstrate that knowledge. So there are some examples there. By no means an exhaustive list. By no means indicative of all of the different types and of all the different types of projects and languages and technologies that have been pursued in this class. But it gives you a little bit of a head start. Another one that was really good that I don't have up here, but I probably will put up here, is Last Quint. A student is really interested in gaming PCs and building machines. And so he asked, can I document the process of building a gaming machine for my cousin? He's given me the money. So I'm going to go out and buy all the parts. I'm going to describe what the parts are. I'm going to put them together. I'm going to show you how you set up a gaming machine, how you install an operating system and the correct drivers and things like that to make it work. And I said, okay, that sounds interesting to me. And he did a fantastic job. He just took his phone or webcam or whatever it was and showed all the parts that he had bought and why he had bought them, and just did a very brief description of each thing. Here's the motherboard and here's why I chose it. Here's a graphics card and here's why I chose it. And did a really good job of documenting the entire process of setting it up, and then also installing the software and the operating system and showing the screens that you should see, if you're doing it correctly. And there were a couple of bumps along the way, as there usually is when you're either building hardware or installing software, and he showed how he got around those hurdles. And it was just a great project, and it turned out much better than I expected it to. So that's not up here, but that was something that was done last semester that really impressed me. So I might put that up there as well. But I try to leave these final projects as wide open as I can. It's intended to be you being able to spread your wings a little bit and explore something that we're not necessarily doing in class, but that you've got an interest in. That doesn't mean you can't do a project based on things we've done in class. Obviously, Scratch is a popular option, but you do have the flexibility and the freedom to go outside that. If there's some technology or software or hardware or whatever that you're interested in, just run it by me via email, and I can give you some tips and advice and go for it. I do ask that students just send me an email and say, this is what I'm planning to do. Is this appropriate? And the reason I ask for those emails is more to protect you than anything. If you send me an email and say, I want to do this, and I know how much work's going to go into that, I expect like 10 to 15 hours of work on this project. And if you come to me with a project that I know is going to take you 50 or 100 hours, at least I can tell you ahead of time. I can say, usually I'll say something to the effect of, it's perfectly acceptable. If you're interested in that, you want to go that direction. What you need to know is that this is likely not a 10 to 15 hour project. This is going to take you much, much longer. And if that's the case, then it's in your hands. Do you still want to pursue it? And often what students will do is they'll isolate like a 15-hour chunk of a larger project and say, I'm doing this on my own time, but for the class, can I isolate, the first 15 hours of this project and document, what's going on, or provide me with code of the first working chunk of the program, whatever it is. And that's something that we just discussed depending on what your project is. So if you are interested in a larger scale project that you're going to do on your own time anyway, and you want to take a section of that and use it as your independent project, students have done that before, and it's worked out just fine, as long as we communicate ahead of time and I understand and you understand what's going to be expected to be handed in. The only other thing I ask is that it has to be related somewhat to what we're doing. Now, if you're doing programming, it's logical that you need to have all 5 basic components of programming in your final project. If you're gonna do a program of any type, it's got to have variables, data types. It's got to have functions that you've created. It's got to have conditional statements, if statements. It's got to have looping and input-output processes. So that handles the 5 sort of major concepts in computer science. And if you're going to build something using software for a final project, if it doesn't have those, it's not complicated enough to be sort of a worthy final project. But if it does have those elements, you should be good to go, and really wouldn't be able to make a decent project without them anyway. So when I assess the assignments, I've got a bit of a rubric up. And I'm looking for integration of those 5 key concepts. I'm looking for usability. I'm looking for error checking to see, to test it and make sure that it works properly. And I'm also looking for a challenge level. And that one's not too strict, but I can tell if it's a project that should take you an hour, and a project that should take you 10 hours, and a project that should take you more than 10 hours. So if you just kind of slap something up there, you're certainly going to lose quite a few marks on the challenge end of it. I've gone into academic integrity a lot in this class, and so far people have been good. I haven't had any concerns about people copying others' work or using other people's work inappropriately. But if it's going to happen, this is typically when it happens. Students leave this project to the last minute, and they panic, and then they go find something online, copy paste, change a few things, and submit it. And again, those are really easy to catch. Your teachers know about what level you're at. So if you're doing high school level programming, and all of a sudden you turn something in that looks like it's made by the software developer working for Microsoft, it's pretty obvious that you copied it from somewhere, and then it's just a matter of using Google to find out where it copied it from. So just don't. And there's no need to do it, right? I mean, if you're having trouble, just email me and I'll help you through it. I understand life happens and whatnot. People fall behind, but there's really never any excuse to steal anybody else's work. So like I say, if it happens, it tends to happen in this section, and it doesn't need to. It really doesn't need to. So I just keep that in mind. If you're struggling with it at all, shoot me an email, and we'll work our way through it, and everything should be good. So there's some sample projects, and then if you click down the other items in this folder, this gives you a reasonable idea of what I'm looking for in this thing. And again, I try to keep it pretty wide open so that you pick something you're interested in. There's a documentation section, and the documentation section is most of the information is inside this document right here. So make sure you click on that document to ensure that you're getting all the important elements into whatever documentation you submit. If you're working in Scratch, if you're working in Scratch, there isn't really a great way to do internal comments like we do in Reborg and Python. So you don't have to do comments for Scratch, but you still need to do a Word document or something that indicates the things that you might have put into your code if you had that access in Scratch. And if you're doing something in Python, it would be expected that you have information in the Word document that I ask you to submit, as well as inline comments in your Python files. So I've tried to remind people at every opportunity for Reborg files, just have a couple of brief comments about the important functions and the important structures. If you've got a big loop that does a lot of things, it's helpful to have a line or two above it to just tell the user this is what's supposed to be happening here. So I've been trying to get people into the habit of doing that on Reboard because it's a requirement for every assignment, every program inside the Python unit. So if you've been doing that for Reboard, just carry on your documentation with the inline comments. And again, they don't have to be too long. If you're commenting every second line in your program, you're doing too much. You just need to comment the major structures and the things that that are the major drivers of your program, which is typically custom functions that you make, and any big loops that do a whole bunch of stuff in order to achieve your goals. And then there's a project self-assessment sheet, which is just you download this and you fill it in yourself. It's a Word document. You can just highlight where you think you are on the scale, or put a little X in the box that you think suits that reflects your performance, and then you just submit that to me, and I use that as part of the final grade. It's just a rubric. You don't have to type any additional information. You basically just have to pick where you are on the scale for each of the items. So that takes care of the final project. Before I move on, are there any questions about that? If there are, I am happy to field them. And hello, Ella. Didn't see you there. And Claudine, welcome. So, any questions about final projects? Did I put everybody to sleep? It's like Mr. Stridham's still awake. Okay, well, before I move on and do some work in PyScripter, somebody type something so I know that you're still connected and that you can still hear me and see me. There it is.
Yeah.
Thank you, Romilly. And oh, hey, Zane, I didn't see you there. Possibly. Okay, excellent. All right, now I'm just going to do some very brief stuff in Python today because this is the first day that we're officially doing Python, and I want you to have time to move through the videos and the presentations and the additional information in Python, and download the whatever IDE you want to use, and sort of introduce yourself to it. But I'm just going to go through a couple of the major structures that you're going to see in Python and show you how they relate to what we've done in Reboard so far. So if you feel like you're kind of following this a little bit and then it maybe gets beyond your scope, don't panic about that too much. Each one of these is a very well-defined section inside our Python unit where there's a tutorial video and a PowerPoint presentation and some examples. So I'll share my screen again, and then we'll just kind of move on into Python. Okay, PyScripter. Everybody see my PyScripter all right?
Yes.
Okay, this is what it looks like when you open it, and you see a bunch of code up here that you don't need. Just delete it. Okay. Now, most people have some sort of copyright notice at the top. Whatever, not a big deal. If you have that or not. And then, so what I would do, just so that other code doesn't keep popping up each time, I would save this file. I would go save as, and then I would call it template. And then I would open template every time, and then I'd instantly save as program number 1 or program number 2. But that's up to you. You manage your files the way you manage your files. So this is what PyScripter looks like. And there are a lot of commands in here, but it's actually pretty stripped down compared to a lot of the software that people use for coding, and particularly larger scale projects and integrating web and things like that. So I tried to pick something that was relatively stripped down, and you can rearrange all these windows, so yours might not look exactly like mine when you start. But what's really important is that you have your coding window up top here, and then you've got the thing that's called the interpreter down at the bottom. Python interpreter, because this is where you're going to code, and this is where you're going to see input that you need to put in, and also the output of your program. So the simplest comment of all, simplest step of all is print. You're going to be using print a lot because it's what you, it's the command you use to have the interpreter give output to the user. So the print command is just print. And what you'll notice when I start typing, and another reason I like using an interpreter, or sorry, an integrated development environment, is it usually has code completion, which means if you start typing out a command in Python, it's got a whole bunch of libraries installed that have basically little widgets and programs that people have built over the years, and things that are built right into Python. And the benefit of that is when you start typing something, it pops it up. So print's not a very long command, but you'll notice if I type in P, these are the options for built-in commands that start with P: pass, pow, which is powers, which is exponents, print, and property. And so if I'm typing and I want to do a print statement, if I type in PRI, now print is the only thing on the list, and it's the thing that's highlighted. Even if I just type PR, it's the top thing on the list, right? I assume the list is just alphabetical. So as soon as you see it highlighted on the list, it also has a little box that tells you what it does. It says it prints the values to a stream, and then it also tells you what it needs. So what it needs to work is a bracket, and then it needs some sort of value. And there's some additional information in here, and then an end bracket. So really all you need is print, bracket, a value. So that's whatever you want to type. You know, if it's a you know, it might be a word, it might be a number, and then an end bracket. So you don't have to know any of this to use this. You know, I want to use a print command. So when you hit tab, it fills it in for you. So you don't have to type anymore. And then you know you just need a bracket. And you notice when you hit one bracket, it puts the end bracket in for you too. So that's handy. And then you just need to put quotes in whatever it is that you want to type. And then next line. So if I print again, just hit tab, open bracket there. Oops. Go to the end, go down. And now when I run my program, which is up here, it's run. You can also use Control and F9 if you want the keyboard shortcut. So Control F9. And what it does is it says remote interpreter initialize. That just means I'm working. And then it prints out the two things I asked it to print out. I said print hello. I said print there. And you see it prints that. So that's the most basic command. And the one you're going to be using most often is print hello, or sorry, print, the print statement. Okay, now what I'm going to do is I'm going to go back to Reborg, and I'm going to go back to Reborg's keyboard, and maybe, I don't know if I can bring this over or not. I can't bring that over. But what I'm going to do is I'm going to highlight some of the structures that we used in Python, or in Reborg, and show you the equivalent in you know, sort of hard-coded Python. We've made a transition from a highly visual, very stripped-down language in Scratch, which is, by the way, is partially built in Python, where you basically drag and drop blocks, and there's no chance of making, or very little chance of making syntax errors, so having spelling mistakes that affect your program, or missing a colon or a comma or things like that. It's pretty bulletproof, which means you can just drag things in, hook them up properly, and then you can see your results on the screen. So it's a highly visual language, and it's not syntax sensitive is the way we would say it, meaning you don't have to type in a lot of your own code unless you're using variables and broadcasts. So there's very little chance of making error. And so that's your gentle introduction, right? Very visual, so you can see what's happening, and there's very little chance of making errors when you're coding. And we move to a kind of a half and half Reborg, where you can still got a strong visual of what's happening and what your commands tell Reborg to do. But there's definitely, as you no doubt noticed, there's a lot more chance to hard code things in yourself, and things like white space and brackets and colons and other parts of language, all other syntaxes are very important, because if you miss colon in one of your Reborg programs, it breaks completely, nothing happens. And that's the same way in Python, right? So you've still got the visual element in Reborg, but you're also coding and using structures that are very similar to this language we're learning now. Python, sort of, this is the main Python. This is what it looks like for developers all around the world. And now we're backed out of the visual element to largely code and syntax and words and our input is words and our output is words. There's not going to be a whole lot of visuals other than this command line stuff down here, and the focus is shifted more on solving problems using logic and building functions and building your code to solve data analysis problems with dollar figures, problems with words, problems with statistics and things like that, which is just a huge component of learning computer science and actually having applicable skills in a career setting. So that's why we made that transition, and we're finally at the place where we have very few visuals and our syntax is really important. And hopefully by moving through it the way we've moved it through it, you're prepared for that. Because if you forget something, let's say I forget a quote on the end of there, you'll notice it does tell me that there's a syntax error, but when I run it, it will just break, right? And it says, you made a mistake, and it does its best to tell you what the mistake is, but unless you've got a relatively large programming vocabulary, you won't know what most of this stuff means. You'll know what a syntax error is. You might know that EOL stands for end of line, but while scanning string literal, you might not know what that means. You might not know why it says file module, but the important part is it points to the thing that it thinks is wrong. Print there, and there's a little arrow indicator there that's trying to tell you should probably put a quote in there, otherwise I'm not going to work. And this one was relatively easy to troubleshoot, but you're going to have, you're going to make mistakes on if statements, and you're going to make mistakes on loops and things like that. And the helpful error message you get might not be all that helpful. It also might not point you right to the mistake. You notice this one said, hey, your mistake is on line 4, right there, line 4. So it's easy to go find it and fix it. But you need to know that if you get one of these errors and you've got a relatively long and complex program, it might not point you to the right line. In fact, it might misdirect you completely. It might tell you your error is on line 4, but the real reason your program is breaking is line 58. So this is useful, and it gives you a great place to start, and usually it'll help you fix the problem. But if it doesn't, you just need to know that it might think that's where the error is, but your error might be in a completely different part of your program. That's why step-by-step debugging is so important, and that's why I tried to emphasize that in Reborg. I'll just bring Reborg over here so I can share it. Everybody see my Reborg?
No.
Sorry, I had 2 answers at once there. Can people see my Reborg?
We're still on PyScripter.
Still on PyScripter, okay. And let's stop sharing for a second and try to change this so that I'm sharing my screen and not an application. Share your entire screen. There it is. Sorry, I was on the wrong one. Okay, we're down the rabbit hole. And you can see PyScripter?
Yes.
And you can see Reborg?
Yes.
Okay, so I'm just going to kind of flick back and forth on the important things. Debugging is crucial. And step-by-step debugging is how you find out where there is an error in your code. So if I just go into this code and I make a random error right there, I don't know what this is going to do, but I assume it's going to cause me a problem somewhere. So if I go to Reborg and this particular program and I try to run it, and I'll just scrape through it here, there's going to be a mistake somewhere. Ouch, I hit a wall. So that code that I put in right there caused an error, but I can't fix that error, or I can't program around it. I can't patch it unless I know exactly where it happens. And that's why it's really important that you know how to do step-by-step debugging. Okay, it's one thing to run the program. If it works well and it works perfectly, that's great. But if it doesn't work perfectly, you have to know how to step through it. And stepping through it, I've demonstrated this many times before if you've done live sessions, stepping through it just goes one line at a time, right? So the first line of import here is while is not facing north. Reborg is facing north, so Reborg's going to move till he hits a wall, and you can just see it's highlighting as I go through. It's following it step by step, and until I make an error, until I get an error message, I could keep stepping through one line at a time. Reborg's got a nice little slider built in, so I can step through the steps forward and backward as many times as I want. So if I go right to the end, and the end is usually where your error is going to be, but that doesn't mean that the error is the end of your code. Okay, so I hit a wall, and because I've been stepping through, I know that my error is right here. So if I step back one step, that's right before the error. I step forward, and now I can see that this is the last command that worked. And if I go one more step, oh, sorry, that's the last command that works. And if I go one more step, boom, that's where my error is. And that's of crucial importance when you're fixing a relatively long program. Okay? I know that this move statement right here is what got me in trouble because that was the last step, okay, before I hit the wall. So by going through it step by step, I could isolate exactly when the problem occurred and exactly where the problem occurred. Right back one step. It was right there. That was the last step that worked. So that enables me to go into my program and, okay, well, this clearly is where my problem is, so I'm going to delete that. Oops, reload it. So I'm going to delete this, and I'm going to hope that that fixes my problem. And as we can see, it's not because there's another one right below it, so I run it again. And, oh, I hit a wall. And I hit the same wall, but it looks like I have fewer steps. So that hopefully means that I actually fixed a little bit of it. So now I go up to here, and okay, so that's the last step that worked before I got into trouble. Oh, I had another extra move in there. Okay, well now I'm really sure that my error was in this area, and it's probably because of that. So I fix it and I run it again, and guess what? Everything's fine again. So step-by-step debugging in Reborg is important, but in Python it's crucial because you're not always going to have this nice handy visual that shows you in the maze where the problem is. You're going to need to find it in code. So if I make a few more print statements here, and I'll put some variables in. V equals, this one's going to be word, hi, oops, and x is going to be an integer 5, and y is going to be a, let's say that's going to be what we call a float. Don't worry, you're going to learn all this stuff. And let's say that I want to print out, a mathematical statement. And what I want to do is I want to take y and I want to multiply it by v. So I want to print out y times v. And I've made a mistake, and that was kind of the point. And then after that, I want to, let's just say I want to print, done. So my program's done. So when I run this program, there's an error in it. I know there's an error in it because I made it an error. Okay, now it does tell me right here that there's an error in line 10, and because this is a super simple program, it's right. My error is in line 10, and it's telling me my error. I can't multiply that because one of them is a float, which is a decimal. So what it's saying is, if we look at what v is the word hi, and y is 5.5. So basically what I told the computer to do is, hey, multiply hi by 5.5, and that doesn't make sense mathematically, right? We can only multiply numbers. We can't multiply the word hi by 5.5. So it was a logical error I made. I probably wanted to multiply it by x instead. The point is, it broke the program, and it never got down to the done statement. Okay? It got to hello there 5, and then there was an error. Now this one's actually even easier to troubleshoot because I have things printing every line, so I can tell exactly where it stopped working. But your programs are going to be a lot more complicated than this, and you need to be able to step through it line by line to find out where the error is. So this is probably the most important thing I can teach you in the Python unit, is how to debug your programs, because it'll just save you a ton of time when there's mistakes. PyScripter debug is right next to the play button, but it actually doesn't debug. The real thing you need to do is the thing that's called step into subroutine, and it's F7 or this. What this does is it allows you to step through one line of code every time you hit the F7 key on your keyboard. This debug process does actually go through your program, but sometimes it doesn't start at the beginning. Sometimes it's starts in the middle, and sometimes it gives you some really convoluted messages down here that don't end up helping you all that much. So I recommend that if you are going to be debugging with your PyScripter, so I'm just trying to get through it here. I'm going to stop debugging somehow. I never use debugging, so I'm not actually sure how to turn it off. There you go. Okay, so why am I having trouble stopping this debugger? Stop should be available. There we go. Okay, stop. Okay, so now I've got my program. I know there's a mistake because I tried to run it and I got an error. I want to step through it line by line. So this is the one right here, step into subroutine. You can click on it or you could just hit F7. And what it's going to do is it's going to show you highlighted which line you're on, and it's going to run through your program. And as long as your program's working, it's going to continue to print the output down here, but it's going to show you where the mistake is. And the other important part about using the step-by-step debugging is you're going to be using a lot of variables. Okay, you're going to be using a lot of variables and things that are called lists and looping. And what you want to be able to do is see what those variables are at any given point in time. Because if you think that a variable is supposed to be equal to 5 at a given point, and it's actually equal to 7, there's a mistake in your program, but it might not actually break your program. Okay, you might be getting the wrong numbers, but there's nothing that actually halts the program. You're just getting the wrong output. I expected my output to be 5, and it was printing 7 for some reason. Well, that's a perfect example of why you would want to step through your program while looking at what each variable is each time. Now, I don't have it set up right now, but it's down here. So there's a little variables tab down here. And again, this looks different depending on which IDE you use. So if you're using Thonny or if you're using PyCharm, it's fine. It will have this. It just might not look exactly the same as mine. And if you have trouble finding out, where do I go to debug step by step, or where do I go to see what my variables are while I'm debugging, I can help you troubleshoot that really easily. So I just took the little variables tab down here and I put it beside. And the reason I did that is because I want to see what these variables are every step of the way in my program. So I'm just going to keep hitting F7, and you can see this arrow and the blue indicates what line I'm on. So I hit F7 and it moves to the next line. And down here, you'll notice it did the thing on the line up here, right? So it did this line successfully. It printed out hello down there, and it tells me, okay, now I'm moving on to the next line, which should work as well. So it prints it out. Now I'm going to print 5, and that works as well. Now I'm going to set a variable. Now this is important because it doesn't print anything for these 3 steps, but just because it's not printing something doesn't mean that it's not doing something. So this one is saying, I want to create a variable. I'm going to call it v, and that variable is going to be equal to hi. And as long as you've got the quotes in here, Python knows that hi is a word and not a number or anything like that. So when I run this step, nothing's going to happen down here. But if we look over here, this v popped up under my locals, and it's just a local variable. So all this is telling you is you created a variable called v. The type of that variable is a string, which is a word, and the value that is assigned to v is hi. So I can always look at this little variables window and know what each of these values is equal to. And if it doesn't look right in here, it's easier for me to find out exactly what step went wrong. So I'll keep going because I haven't hit any errors yet. Okay, for that step, I made another variable and I made it equal to 5. And you'll notice the x popped up here. So x is an integer and it's equal to 5. And I look at this and I say, well, that's all going according to plan so far, so that's good. I run the next line, and now y pops up. Y is a float, which is just a decimal, and the value is 5.5. Well, that looks good, so everything is going well inside here, and now I try to run the next line, and that's where my error is. So at the point at which my program breaks, I know which line I'm on, and I also know what all my variables equal. So it should, between those two things, I should be able to fix it. And my thought process in this would be, I have to look at this line more carefully. I have y times v. V is a string. Well, I shouldn't be trying to multiply a string by a decimal. So at that point, I know that I've fixed my program. And by the way, as soon as it breaks, your debugging session is done. So now I can go back to my program and I can change this. And I can say, oh, I multiplied y by v. I really meant to multiply y by x. Okay, so I think I've fixed my program, and the first thing I would do, I would probably run it, but if I wanted to step through it and see what was happening again, okay, and you know what, maybe I'll actually make x, instead of x being 5, at some point in my program I'll change it to 6, and you'll see why in a second. So it says x equals 5 up here, and then it says x equals 6 down here. That's actually not a problem in Python. It will change the value of x. Remember, it always works from top to bottom. So x is going to be 5, but it's only going to be 5 for this line, and then I'm going to change it to 6. So let's step through it again. So as I step into it, I'm going to do the same thing I did before, just hitting F7, skipping through the stuff I know works. And now I get to x, and it sets x as a variable, which is an integer, which is 5, no different from last time. Y is a float, which is decimal, 5.5. Now this is new. So if at this point in my program, before I've run line number 9, the variable x is equal to 5. But my next command says, oh, I want to change that to 6. So when I run this line by hitting F7, now you should notice x changed. Okay? And it's actually now red. I didn't know it did that, but it's probably red because it's indicating a change has been made. So instead of 5, you'll notice that x is now equal to 6, which is what I wanted it to do, so that's fine. Here's where the error was before, because I was trying to multiply high by 5.5. I've now changed it so that I'm trying to multiply 5.5 by 6 and print the result. So this won't break this time. And as you see, it printed 33, which is the correct answer. I have no errors. The last line of my program, I hit F7 one more time, it prints done. So my program worked from top to bottom. I got no errors. I was able to step through it line by line to see exactly what was happening with every step. And I was also able to track all my variables up here and see what was happening as I stepped through my program. And between those two techniques, you will be able to solve almost all of your problems. The students run into trouble in this unit because they don't know how to debug properly. So when they make mistakes, they're often easy to correct in the early part of the unit. But once you get to the larger programs where you've got, maybe 50 lines of code, if you don't know how to debug, you basically have to look at that 50 lines of code just with your eyes and try to read through the program in your mind and see if it makes sense and remember what your variables are and whatnot. It's just a horribly inefficient way to try to solve a problem. It's so much easier just to go through it line by line, and then when it breaks, you know exactly where it breaks and you know what all your variables are equal to. So I can't stress that enough. Knowing how to debug in Python is just of crucial importance, and take a little bit of time at the front end of the unit to learn how to do it and to practice it, because it'll save you hours and hours and hours later in the unit. So that's my advice. I'm just going to drag my variables down here. So that's debugging. Again, if that was relatively quick, that's okay. You can always go back and watch this video later. And if you didn't understand what I was talking about with ints and strings and floats, that's all part of 4.2, I believe. So don't worry, that learning is still coming. All right, I'm going to flick back over to Reborg's world. We talked about debugging. So let's look at some of the major structures in Reborg. This isn't my code, by the way. I just borrowed this from a student. In my library, I've got a bunch of definitions, which are functions. In in Python, there are also libraries, and you will use some of the libraries that are built in, and you will use some libraries that other people have made to make your life easier, but we're not going to be building our own libraries in Python. It's a little bit past where we need to go. So whenever we're building functions in our programs, we're going to do it inside the main code window. And it's the same thing as if you were in Reborg and you did your instead of importing, you just made a function at the top of your main code. Okay, so that's the approach we're going to take when we're doing our Python. But I want you to know that libraries do exist. We're just not going to be building them ourselves in this class. So if we go side by side here, scroll over. Let's just look at a function in Reborg, and I'll do something somewhat similar in Python. But we have to remember that all of these built-in commands in Reborg, they don't exist in Python. These commands were all made specifically for the visual environment and turning a robot and doing things with a robot. These aren't real, these aren't going to help us in Python, but the way that they're built is going to help us in Python. So what I'm going to do is I'm going to make a function inside Python and just basically mirror a process over here. But instead of turning right, what our function is going to do is it's going to print hello world. So you'll notice that the actual process of building a function is very similar. So you start with def, okay, and then space, and then what you want to call it. I'm going to use camel case because I don't like snake case. I like camel case better. It's shorter. So I'm going to make a function that I'm just going to call hello world. You'll notice it also color codes things as you're typing, and that's just one of those sort of little built-in helpful things inside PyScripter that helps you easily recognize what's a function, what's a variable, what's different structures. So it's just Don't worry if things are in different colors. That's supposed to happen. That'll happen in Thonny. That'll happen in PyCharm. Anything you decide to use. So I'm going to say hello world is the function name, and then I'm going to use the 2 brackets just like I did in Reborg, and I'm going to hit the colon just like I did in Reborg. Everything's exactly the same so far, right? So now in the next line, what do I want it to do? I want it to print something. Now we never used print in Reborg, but print is one of the things you're going to use in Python all the time. So what do I want it to print? I want it to print hello for one line, and then the next line I want it to print there, or world, or whatever I said it was supposed to be. Hello world. And you'll notice it automatically indents you to where it thinks you should be, just like in Reborg. And white space is as important in our regular Python as it is in Reborg. Things need to be indented properly. Things need to be spaced properly. Otherwise, your program's not going to work. So as I mouse over this, you can see that it actually even pops up a little. Actually even pops up messages every once in a while. I might have killed it there for some reason, but lost my pop-up. Anyway, there was a pop-up there that said, hey, this is a function, and this is what it does. So there's all these little helpful hints that you may or may not use. So that's it. That's the end of my function, and now I have to just run my function, and I run my function the same way that I run it in Reborg. All you have to do is reference it. So I just go, hey, run hello world. You notice I'm using that tab a lot, right? Again, when you've got code completion, why would I type out hello world when I could just type in HDL and then hit tab, and then I just need to put brackets? So I'm running hello world just the same way that I would run turn right inside Reborg, except in Python, it's going to do something different. I'm telling it to print hello world. So there I go. I run the function. It prints hello world. So really, moving from Reborg into Python, a lot of this stuff transfers right over. I mean, the individual commands for turn right and things like that might be different, but a lot of the way that things are built looks exactly the same, and that was the whole point, right? So that's how you do a function, and we're going to go well beyond this with our functions. We're going to go into what I call fruitful functions, and that's something like this. Instead of just running a function, I'm actually going to send it some data. So I'm going to send it some data, and it's going to print what I want it to print. So instead of printing hello world, it's going to print whatever I send it world. So let's say I send it 6. Okay? What it does is it shoots this 6 up. It says, okay, for this function, x is going to be equal to whatever I sent it, which is 6. It's going to print 6, and then it's going to print world. So I run my program, and it prints 6 world. Now I can change this, right? I can make this anything. I can make this hi. So now it's going to send it hi and print out hi world. So the point there is we're doing something a little different than we did in Reborg because we're actually able to send our functions certain pieces of data now instead of just having to run it. We can have it run with data as opposed to just running whatever happens to be under it. So that's functions in a nutshell. Again, if any of this kind of feels like it's over your head right now, you don't need to panic. I'm just going through some of the parallels. All right, so we've got an if statement. So this is conditional. If statements work exactly the same. I'm going to get rid of my function. I'm going to set a variable x equals 5, and I'm going to set another variable called y equals 3, and I'm going to set a third variable z equals 5. So 2 of those variables are the same. I'm going to make an if statement, okay? And what I'm going to do is if x equals and equals, if you're checking if something is, if you're comparing 2 pieces of data, and you want to check if they're the same, you have to use 2 equal signs. Again, that's something you will learn. If x is equal to 3, I want it to print, if x is equal to y, 3, which is 3 right now, I want it to print, I'm not going to print this because it shouldn't print this because we know that 3 isn't equal to 5. I'm just demonstrating the if statement. Okay, so if x equals y, it's going to print that line. And then you've got an elif, which you've used in, you've got an elif, which you also used in Reborg. And my elif is going to check something different, because that's what it does. Oops, not colon. Elif x is equal to z, which we know it is. Okay? Then we're going to just print a line that says 5 is equal to 5. And then I'm also going to have an else down at the bottom, and that else is going to print Okay? And none of these values are equal. So if we look at the variables I set up here, we can tell which one of these we think will run. X is 5, Y is 3, Z is 5. So if 5 is equal to 3, that's false. So it's not going to do this one. It's going to skip to the elif part. Then it's checking, is 5 equal to 5? Well, that's true, which means it's going to run this part, and it's going to print 5 is equal to 5. And as we know from Reborg, it only runs one of these. It'll run the if, or it'll run one of the elifs, or it'll run the else, but it'll never run more than one of these conditions. So let's run it and let's make sure it works. So we expect it to print 5 is equal to 5. And it does. And if I step through it, then we'll have a very in-depth understanding as to why that's happening. So if I'm stepping through it, x equals 5, it's telling me I set a variable, and my variable's over here. You can see x is equal to 5, y is equal to 3, z is equal to 5. Now it does the if statement. So if, and then you can just mouse over the variable, by the way. So if x, and then I mouse over it and it says, hey, this is an integer and it's 5, equals y. Hey, this is an integer equals 3. Okay, so if I'm trying to troubleshoot, it's super easy. So it's going to run this, and we would expect it to skip over this print statement down to the elif because those are not equal. And it does, right? So the if was false. Check the elif. Is the elif true? Does 5 equal 5? Yes, it does. So we expect this to be true, which means it's going to run whatever's underneath it. So now it's running print. Now it's printing, and now the program's done. It doesn't go to the else. It only does the first one of these it hits. So it skipped over the if because it wasn't true. It ran the elif because it was true, which means it knew it didn't need to do the else. So the way that your conditionals, your if statements, and your elifs and else are structured is exactly the same as in Reborg. This one doesn't have an elif, but this one has an else, right? This is a nested one. It's an if statement inside an if statement, but you notice this one's got an if and an else, and I don't know if there's any elifs in this particular program, but you will have seen elifs in Reborg. It's coded the exact same way, right? It's if something, and then you've got a colon, and then you've got it indented underneath, and then you've got an else that's lined up with the particular if that it's related to. So if this if statement needed an else, it would have to be lined up down here. If this if statement needed an else, it would have to be lined up there. And that's just the white space that's really important with Python. So we ran it, and in this particular instance, we ran the elif. Let's change our values up here so that it runs this else. So if I change the value of z to 4, we would expect a different output. None of these are equal, so it should be false. Elif should be false, and the else should run because it's the only other thing left. So let's run it, and we would expect none of these are equal to print out, and it does. And if we step through it, again, logic says, as I step through this, it sets our variables. Okay, and this should be false. Okay, x is 5, y is 3, so it skips that. X is 5, z is 4, so it skips that. Now we know it's going to run the else because that's sort of the catch-all at the bottom. So it should print none of these are equal, and it does. So that's a really good example of how you use conditional statement. And that's a very good example of how you use a conditional statement and debugging there. And it's very, very similar to what you would have seen in Reborg. So that's a quick if statement. I'll do a quick while as well. So we dealt with one of the conditional structures we're going to use, the most important one, the if statement. And now let's do a while loop. So what we're going to do is set up our while loop. And while works exactly the same way. So while some condition. Okay, now the condition isn't going to be built in like it is in Reborg. It's not going to be something like at goal or something. Let's maybe do something like while x is equal to 5. Okay, what I'm going to do is, as long as x is equal to 5, I'm just going to print the statement. Okay, I'm going to print the statement that x is equal to 5. Now, at some point, my user is going to give me input that x is not equal to 5, x is equal to something else. So I'm going to make an input statement. This is just how you allow the user to type in some data. So the way you do it in Python is input, and then you give them a message, type a number, and then you don't need to worry about this part. You will learn how to do this. So I'm going to set x equal to, so I'm changing what x is. integer, you don't need to worry about the int, blah, 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 blah. You'll learn how to do all that. The whole point of this line is I'm going to be able to type in a number and whatever number I want. So what's going to happen here is I've got a statement that says I want you to loop infinitely until I tell you to stop, right? This is why we use a while instead of a repeat. If I know how many times something needs to repeat, then I'll use a different statement. But as long as there's something out of our control, okay, that this program needs to loop until a certain point, that's when we use a while. So our whole point here is while the variable x is equal to 5, I'm going to run everything under here. So the first thing it's going to do every time, it's going to print x is equal to 5. Then it's going to ask me, hey, type in a new number. And if I type in 5, this should keep running and running and running and running every time I type in 5. However, if I type in something different than 5, this while loop ends, and I'm just going to print out done. Let's see how it works. I run, it prints out x is equal to 5. Then it says type a number. So I'm going to type in 5. And it says x is equal to 5. Type in a number. And every time I type in 5, this while x equals 5 is still true, which means it's still going to do everything under the while, just like it did in Reborn, as long as I keep typing in 5. Now, if I type in something different, like 4, now it knows I'm done. So that is exactly the same way as it works in Reborn. Okay, while will just keep looping infinitely until some condition is met. And the condition in this case is when x equals 5. So I'll just step into that just to show you how it's working line by line. Sets our variables. Okay, now it looks at this and it says while 5 equals 5, so that's going to be true. Okay, so while 5 equals 5, I'm going to run this. So I'm going to print x is equal to 5. Then I'm going to get some input from the user, and I'm going to type in 5 this time. Okay, so you'll notice x is still equal to 5 here. Now it does this test again. Is x equal to 5? Yes, it is. So I'm going to run this again. I'm going to print x is equal to 5 again. Now I'm going to ask the user again, what number do you want? Now I'm going to type in 4. Okay, now it goes to the test again, and it says, does 4 equal 5? Now it's false. As soon as the while condition is false, it skips over it, and it goes to the next line, whatever the next line is, and the next line down here is print done. So your while loops are essentially exactly the same in Python as they were in Reborn, and that's by design. The one that's completely different is repeat. We have a handy little repeat function so let's say I wanted to print hi. Oops. I should actually put some real code in for that. Let's say I wanted to print hi 4 times. So I say repeat for print hi. Now in Reborn, this would do whatever's underneath it 4 times, but you'll notice that it's got a red syntax error thing. That's because repeat does not exist in Python. They did it that way in Reborn because it's kind of simple and easy to remember. But you can do the same thing in Python. It's just a different command. And what the command is for. It's called a for loop. So the 2 types of loop you're going to use are a while loop and a for loop. So the while is the same as in Reborn. The for is just repeat in Reborn. So what you do is you just say for some variable, and it doesn't matter. You call this x, you call it y, you can call it hi, you can call it whatever, almost whatever you want. For hi, okay, in range, and the range is going to be a number, and in this case, I'm going to say 3, colon. For hi in range 3, print hi. And all this is saying is I'm going to set a variable called, I'm just going to make it x. I'm going to set a variable that's a number, it's an integer, and then as long as it's in the range of 3, which means it stops when it hits 3, I'm going to do whatever's underneath it. And then every time I'm done this line, what it's going to do is it's going to print, it's going to change x. So x starts out at 0 because computers start counting at 0. And then after it does this the first time, x goes and it's 1. And then x goes and it's 2, and x goes and it's 3. In fact, I'll print out what x is here. Okay, so I'll print out what x is right there. So as I run this program, I'll just run it, and you see it prints hi, 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 and then it printed 0, 1, 2. I'll get through it here to show you how it's like the repeat command. So we set I actually don't even need variables on this one. And I don't want to confuse you. This x, by the way, is not the same as this x. Okay? And you'll learn why later. So all I've got in this program is for x in range 3, print hi, and then print whatever x is. So when I step into it, the very first line is for x in range. If I mouse over x, it should tell me that x is 0, but it will in a second anyway. So you see x is an integer and the value is 0. This is a range command, and it's going to go up to 3, which is just an integer. So what it's going to do is it's going to print hi the first time, and it's going to say right now x is 0 because it starts at 0. That's the default. So x is 0. So I'm printing it out. Now it goes up, and what you didn't see happen is after it did this for loop the first time, it adds 1 to x. So now it's saying x is going to be 1 after this. So x is 1. So what this top line is doing is saying, is this number still in this range? And the range being 0 to 3. So x is 1 right now. It's still in the range between 0 and 3, which means I'm still going to do what's underneath it. So it's basically I've repeated this thing once, right? So if I had repeat 3 on here, this would be the first time it's repeated. It would have printed it once, and then now it's printing it again because it's a repeat. So it does it, and it says currently x is 1. Now it changes x right now. Okay, and now you see x is 2. You can see that little pop-up. So now it's making the comparison, is the number 2 inside the range of 0 to 3? And the answer is yes. So it's going to print again. And it's going to say, I think x is 2 right now. Okay, now here's kind of the tricky part about counting in computer science. Now x is equal to 3, or at least it will be when it runs this line. It should be, in sort of plain English, if you say, is 3 in the range 0 to 3, you would say, yeah, it's the last number in that range. But the way that computers count is it actually stops when it hits that number. So what this line is going to do now, it's going to say, is 3 at the end of range 3, is what it's really saying. And the answer to that is x is the same number that you've got here, which means I'm done, which means I'm going to skip over, I'm going to end my program. So that's what happened on that one. And it doesn't matter what you change this to. You can change this to 5, to 100, to 1,000. It's going to do it. It's going to do the exact same logic. It's just doing it more times. You'll notice the last x printed is 99, because when it goes up after this line here, it says x now equal 100. So after x is 99, x is 100, it says is 100 at the end of this range? Yes, it is. So I'm done, and I'm not going to print hi and 100 again. So for loops are repeats, and there's a bunch of different ways to do this process, but this is probably going to be the one that you're going to use most often. And we'll get into all of those different looping options later, but you need to know while is the same, and you need to know that instead of repeat, you're going to have to use something called a for loop. So that's looping in Reborg. And I already showed you input and output down here. So the only other thing that we're not dealing with is data types. And the quick, because you don't really have data types in Reborg, the quick and dirty method explanation is if I say x is equal to 5, I'm basically just setting a variable and putting a value in for that variable, just like in math class. X can be whatever I want it to be. In this case, I want it to be 5. 5 has no decimals, and Python is smart enough to recognize that I typed in a 5, and 5 is an integer, so it knows that the type of this is an integer. Lots of other languages, you have to define it. Like you'd have to say something like dim integer as value equals 5 or something like that. So there's a lot more code in a lot of different languages. Python is supposed to be like one of the easiest scripted language, one of the easiest syntax-based languages to learn, because it does things like this. It detects what type of number this is, and it automatically sets it as an integer. And your commenting, by the way, is the same as it is in Reborg. I just put the little hashtag and then just telling you that that's an integer. I'm going to say y equals 5.5, and because I put a decimal in, Python automatically knows this is something called a float. So this is new language, but what a float is just a decimal. So whenever you hear the word float in this unit, from here until the end of the quint, when you hear float, it means a decimal number. And it doesn't matter how many decimals. It could be 5.5, could be 5.535, blah, 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 blah. Okay? And then I'll set another variable, z is equal to hi. This is something called a string. So all you need to know about a string is words or letters, and including spaces. It can have sentences, it can have characters, it can have numbers in it. Anything in between the quotes, it's going to treat as like a letter or a word, including the space. So that's a string. That's a data type you're going to use. And then the other one is Boolean. So A equals true is an example of Boolean. B equals false is an example of Boolean. And Boolean is, all this means, This is a new word. It's named after a guy named George Boole, and all it means is it's either true or false. I don't even know how I could describe that any better. If you're checking if something is true, or if you're checking if something is false. So these are both Boolean. And a way you might use it is something like this. Print print A plus A. I don't know why I printed 2 there. Oh, because if something's true, it's equal to 1. Never mind. You don't need to know that. That's actually way beyond. I'm going to say print X equals Y. Okay, now you see how it said false? Okay, that's an example of Boolean. So I said, hey, print the result of is 5 equal to 5.5. And it says that's false. Okay, that's why it printed false. But if I changed my logic here to say print is X equal to 5, now it's going to print true. Okay, so it's basically true or false is the only Boolean you need. It can't be both. It always has to be one or the other, and that's why if statements work, and that's why while statements work. It's either going to run the if statement or not. It's either going to run the elif or not. It's either going to run the loop or not. Okay, there's no option. There's never an option of am I going to run the loop? Maybe if I feel like it, right? Computers only do exactly what you tell it to. So you use Boolean all the time, but you need to know that you can also set variables equal to Boolean. Okay. And if I told it to print B, I think it might print 0, but well, let's see. No, it prints false, and so A should print true. But if you do math with Boolean, true is 1 and false is 0. So if I try to do math with Boolean, I think that's why I was getting those numbers. Okay. Whereas if I used a keyword like and, again, this is later. I don't want to confuse you. I just demonstrating the variable types. So those are the types of variables you're going to work with. You're going to work with numbers with no decimals. You're going to work with numbers with decimals. You're going to work with words. You're going to work with true and false. Just thinking to myself if I missed any. Integers, floats, strings, Boolean. That handles all the major types. There are different types, but they're types that you're not going to use. So that is quick and dirty. Using PyScripter, comparing things that we've done in Reborg to they're going to be done in Python. Again, try not, hopefully you're not intimidated. Remember, all of these things that I went through here, there's like a section based on both of those. So you'll be doing learning and practicing the whole way through. I have used our, almost hour 20 of your time. So I think that's probably a good place to call it a day. Now, aside from, with the understanding that you're not supposed to know all of that stuff yet, did what I go through make sense with regard to comparing Reborg to how things are structured inside Python? Are you seeing similarities there?
Yep.
Excellent. Any other feedback? Romilly said it's okay.
But maybe it just made sense to me because I'm already on the unit, so.
That's true. You're already blazing through Python. Again, the point is not that you memorized everything that I did there or that you even understand what each line of code does. The point was I took something from Reborg that we typed in a certain way and that we ordered in a certain way and that we indented in a certain way. And I showed you the equivalent in Python. And for a lot of those commands, they look very, very similar. That was the whole point of that. So don't panic if you feel a little bit confused right now. The learning materials will take you through that. And also, I'm always here. We're always here to answer your questions and help you move forward. Are there any other questions or concerns before we move, before we color a day and a week? Not hearing or seeing anything, so I'll